Alright guys, today we are going to talk about Introduction to Orthographic Projection. So the first thing you need to be aware of is we're going to talk about views of objects, and in your grand scheme of ways to draw things, we are looking at parallel projection all the way down the right hand side of that chart into multi-view projection. That's what we're going to focus on in this class. And essentially we're looking perpendicular to the principal side of the face of the object, and the primary dimensions we're looking at are width, height, and depth. So when we're talking about orthographic projection, again, that's just a 2D representation of a 3D object. So you can see on the left, there's our 3D object, and then what we're going to do is learn how to go from this 3D representation into this 2D representation, be able to go from the left to the right, and then back from the right to the left. So here's an example here of that exact same shape. So we're looking at the different sides of the object. So you can see we have the front, which is drawn right here, looking at it from that way. We have the top looking down from the screen down to the bottom. You can see there's the surfaces for the top, and we draw that over here. And then looking at it from the right side, then you would see something that looked like that. So that's again going from the 3D representation on the left into your 2D representation on the right. So when we're talking about those three important dimensions, when we look at an object, like this one right here, the left to right is your width, the front to back is your depth, and then here's your height. So when you look at this in, say, the front view, you see your width left to right, you see your height top to bottom, but you don't necessarily see that depth. That's why we have to have more than one way to look at this object, because if you just looked at the front view, you wouldn't see that third necessary dimension. So here we're going to take this object, so here's where we just saw the front view, and if we take that piece in our hand and we turn it to the side, this is what we would see as our right side view. So notice in your right side view, you're seeing the height, okay, and you're also seeing now the depth. So you could take this picture and this picture and put them together and get all three of those views. But it's kind of hard to tell what's going on right here with this little cutout. So that's why we could then take from this front view and rotate it up and get this top view up here. So now notice in the top view you see the width and the depth. So in the top view you're seeing width and depth but not height. So when you take all three of these, the top, the front, and the right side, and you put those together on paper, it would look like this up here in the upper right, and those are called the three regular views. So here's our front view, and again in the front view we're seeing width and height. Here on the right is our right side view, we're seeing depth and height, and at the top is our top view, we're seeing depth and width. So when you put all three of those things together in your mind, then you need to go from 2D to 3D and come back and be able to picture an object that looks like this in your head. And that's what we're going to start doing when we're talking about how to do an orthographic projection. So when we're talking about views of objects, we have three regular views: top, front, and side. And typically that side is usually the right side. Technically, there are a total of 6 views. You have top, rear, left, front, right, and bottom. Now, when you look typically at right and left, they'll kind of look like mirror images of each other. Same thing with top and bottom. Typically, those are mirror images of each other, as well as front and rear. Just depends on the exact shape of your object. So when we think about objects, another thing we can be considerate of is a thing called the glass box method. And there's a video that kind of goes along with this, so I suggest that you watch both. That way you've got a good representation of what's going on with this glass box. But we're going to take this object, whatever it happens to be, put it inside of a box that has glass walls, okay? And each one of those glass walls that we see here are going to represent the 6 principal planes. So if we were to take a picture perpendicular to each one of these planes and look at what our object would look like, we're going to draw that on the glass box. So it's just like we held up a camera and took a picture of it. So now we've got some lines on each one of these faces of our glass box. Okay, so you can see here's some projectors. So this corner right here projects up and matches up right there. Okay, just like you can see this corner right here matches up right there. So we're projecting down, we're looking at how that looking through our projection planes and our projectors. So take a look at surface A and surface B and how those might look if you were to stand above this box, look straight down and take a picture of them. So now we're going to start to unfold this box. Okay, we're unfolding it. We left our little lines on there. We're unfolding it, and now we've flattened it out. Okay, so now instead of having it all folded up together as a cube, we've unfolded it and have flattened it out. And that's part of the glass box method. So I want you to take a second, pause this video, go back in to the next video down in the lecture set, and watch that video that explains the glass box. So you're back now, and we're ready to move on to the next lecture.